Hi everyone, welcome to our project presentation on EmojiCrypt, a fun, secure, emoji-based encryption web application. I am Kusmanjali and I will walk you through the sign up and sign in functionality and give you the quick dashboard overview. We have used the Firebase authentication to handle the user sign up and sign in securely. This app is a secure, emoji-based encryption web tool built by using the HTML, CSS and JavaScript for frontend and Node.js plus Express.js for Backend, Firebase for the authentication and database, and delayed via Firebase hosting. Here is the VS Code. Let us look the HTML form first. In the index.html, we have a separate container for the sign up and sign in, which are dynamically toggled by using the JavaScript. This sign up form collects the username, email, and password. Once submitted, it uses the Firebase create users with the email and password method and stores the username by using the update profile. Now JavaScript, you will see the functions handle sign up and handle logins. This interaction with the Firebase authentication and also record login activity in the Firebase. Let me show how it works. When a new user sign up, they are registered in the Firebase. Which are users signs in, their name is displayed in the top of the corner. Once signed in, users are redirected to the beautiful EmojiCrypt dashboard. The dashboard is split into the two panels. The left panel is for encryption and right panel is for decryption. In the top right, we have the user info plus logout and notification icon and message feature and dark mode. Now my teammates will walk you through how the actual encryption description messaging works both in the browser and in code.
Hello everyone, I am Sindhuja and I will now walk you through all the core functionalities of our app, the actual working part. Let's start with encryption. When a user types a message and enters a password, they can also choose an emoji style like animals, food, symbols, etc. The message is converted to binary, mapping to emojis using a shuffle emoji set based on password. The final emoji sequence is shown with a copy button. You can see the code here in script.js encrypt function. We also prevent encryption if the password or message is missing using validation. Now on to decryption. It takes the emoji input, reverse the mapping, reconstruct the text using binary to text. Both encryption and decryption are client side and password based. Now the real function messenger feature. Once a message is encrypted, the user can send it to any registered user by their username. It is pushed to Firebase Realtime database under notifications or username. The receiver can click the bell icon, view the code, password style, copy or delete the message. For better UX, we auto close the notification pop-up after a few seconds. We have also added a dark mode toggle which applies a dark class to the body. The styles are fully responsive even on mobile view. We have tested this on desktop and mobile. The layout adapts and background image renders properly. Finally, all the data is stored securely. Now my teammate will explain how we handle database integration with Firebase.
Hey everyone, I am Sai Kumar and I will explain how our web application EmojiCrypt is powered by Firebase in the backend. We have used Firebase in two ways. First one is Firebase authentication for sign up and login, and the second one is Firebase Firestore and real-time database for storing and retrieving app data. Let's first talk about Firebase authentication. You can see that in our server.js, we use the Firebase admin SDK to handle user sign up and sign in. When a user signs up, we create their account using admin.auth.createUser. And coming for the login, we verify the email using getUserByEmail method. We also check for duplicate emails during sign up and shows an error if the email already exists. Now, onto the database part. Let's open first Firestore database. In Cloud Firestore, we store structured user related data. For example, in our web application, when a user logs in, we store their login timestamp under the logins collection. The data is stored as logins in that logins, user email, and the timestamp. This helps us track user activity securely. We also check for the extensions of usernames in Firestore before allowing encrypted messages to be sent to the other users. This adds an extra layer of validation to make sure the receiver exists before pushing the message. And coming to the second part, the real-time database. Now let's look at the Firestore real-time database. This is where our messenger and notification system lies. Whenever a user sends an encrypted message to the another user, it's stored under the notifications on the username. Each message includes the sender name, the secret code, password, style use, and timestamp. Let me show you a live example here. This is how it looks like inside real-time database. The receiver sees this as a notification in the user interface using our handle notification function, which is used in script.js file. And we have ensured our user passwords are never stored in Firebase and messages are encrypted before sending. So Firebase only stores the encrypted version, not the plain message. This improves both privacy and security. And coming to the conclusion, this is the our EmojiCrypt web application. Thanks for watching our EmojiCrypt project demo. The GitHub URL is will post in the YouTube description. If you like this, give it a thumbs up and share.